I'm here to explain to you about air resistance. Air resistance is a force between an object and the air. When something moves through the air, it bumps into the atoms and molecules that make up the air. For example, a car. When it moves through the air, the front of it bumps into all these atoms and molecules.
Even though atoms and molecules are very tiny and very light, each collision causes a force on the moving object, or the car. The force from each individual collision is therefore very tiny. There are, however, millions of these collisions each second, so millions of tiny forces add up to make an overall large force.
Now I'll be explaining to you how terminal velocity works. When you jump out of a plane without releasing your parachute, let's say 0.01 seconds afterwards, gravity is going to be working 100% on you, so you'll be falling pretty fast. And air resistance is only be falling about 25%, so about how much? Now let's say about 10 seconds, yeah. Gravity is still going to work 100% on you, but air resistance will work on 50%, so the air molecules will be pushing against you harder, and you won't speed up as fast, but you'll still be falling fast. Okay, now let's say about 1 second afterwards. Air resistance will be working 100% on you, and gravity will be too. And the forces are now at full strength and will balance each other out. When that happens, you've achieved your terminal velocity, which means your maximum speed. Once you've achieved your terminal velocity, you are at constant speed and you cannot go any faster. Air resistance is made up of tiny collisions with the objects that make up the molecules in the air. So the larger the surface area of the object is, the larger, of course, air resistance is, because there will be more collisions between the air molecules and the object. Okay, we want to drop this ball, a normal ordinary ball, from 2 meters, 82 centimeters off the ground. And we'll see how long it takes to get to the ground. Okay, you ready? 3, 2, 1, go. It took 1 second, and its average speed was 1 second to hit the ground. Let's also try it from a parachute. With the exact same thing, the exact same height, with the exact same ball, except this time we added the parachute. Okay, 3, 2, 1, go. This time, the average speed of the ball falling down was 1.9 seconds. This time, I'm going to use an even bigger parachute to see. Doing the exact same thing, the exact same height, right? The exact same ball, but with a bigger parachute than the last one. Okay, go. On the final experiment, it only took 2.5 seconds for the parachute to hit the ball. That concludes our experiment.
Oh, hi, David.
Hey, Nick.
What you doing here?
I'll come and see how the experiment's going.
Good, I made a table.
Oh, can I see it?
Flying bird!
Wait a minute. All birds fly. Except the white ostrich.
I thought it was a flying ostrich.
Really?
Yeah. Cool.
It's good tabling, though.
Thanks.
Okay, should we start talking about it?
Sure, I guess.
Okay. Hi, it's me again, David. I'm here to talk to you about the results for our experiment. As you can see, for each experiment that we did, and each try in our experiment, the distance was 2.82 meters. Okay? With just the ball by itself, the average time of it dropping is 1 second. With the small parachute, 1.9 seconds. And with the large parachute, 2.50 seconds. Now, we calculated the actual average speed of the ball dropping by itself is 2.82 meters per second. With the small parachute, it was 1.48 meters per second. That is three significant figures. And for the large parachute, it was 1.128 meters per second. So we're just doing a final bit on air resistance. Air resistance is a type of force. It pushes against moving objects. Air resistance is also a type of friction. Motorsport vehicles are designed aerodynamically to cut through the air faster than other objects.
It's a really good drawing, isn't it?
Now that you drew it, it has to be that. This streamlining allows cars to be competitive and travel at very high speeds. Wind tunnels, kind of like this, are used to test and try to improve the design of these cars.
The wind tunnels are a lot bigger, aren't they?
Yeah, kind of. That concludes the last bit of information we have. I hope you enjoyed this experiment. Bye.
David was acting, I was filming and editing, and Joe and George wouldn't go away unless I put them in credits.